So guys, we're going to look at the primitive built-in functional interfaces and the binary ones. I don't believe there's a need for us to have another session for method references because we already touched them on our previous lecture. So even the primitive and the binary ones, we are not going to just do a demonstration of them like in code. We are just going to review them and see how they look like. So for instance, we want to start with the primitive ones. So like I said before, the primitive ones will include something like int int to double function. So we see that represents a function that accepts an int valued argument and produces a double valued result, as we can see here. Then we saw the other one, int to long, as you can see, into long. Then we have others. So let's see int to double function. We see that it receives an int, returns an int. This one receives an int, returns a long. But if we look at the other ones, they all they majorly work with types, not primitives, like object types. And we see this one receives a type and returns a boolean. Then consumer takes a type and returns void. So this is one example of a primitive type. So let's look at on the slides. We also have the long, the double. So we can have another one, I believe it's called to int something. Let's look at the classes. We see to int function. To int function. You see it has apply as int, takes t, it returns an integer as a parameter. Then we can look at double to, sorry. We see that double to long, double to int. We see those are the functional interfaces inside function package, as you can see here. Those are the other ones. So the other ones, long to something, it's almost the same thing. So you know how to use a method, an abstract method in a functional interface. Then we have the other versions of the basic one: by predicate, by function, by consumer. You can just look at how they look. I'm just gonna close all the tabs. So if I say by predicate, you see it actually takes two parameters and returns something. Then we have by consumer, it also takes two parameters and returns something. Then we have by function. So we see that by function also takes two parameters and returns something. Those are the differences. So it says represent a function that accepts two parameters. So it represents a function operation that accepts two parameters. So the by functions, as we can see, they are sort of the specialization of the other ones. You see, it says takes two parameters and return the same type. This is the binary operator. We will come to this one. You will see that if I try to say by supplier, I don't have it. But you do see that we have int supplier. This is also another example of a primitive type. So you see it says this is an int producing primitive specialization of a supplier. Let's say int function. You see that we also have int function. It's here. Let's check long function. See, we also have long function, and then it takes a long and returns something. So let's say, can we have int predicate? We do have int predicate. So if we guess without even going to it, it means it receives an integer primitive and returns a boolean. Let's check int predicate. It returns an int and returns a boolean. Double predicate, the same. It receives a double, returns a boolean. If it's long predicate, it will take a long and returns a boolean. Let's check. Do we have what else did I want to check? No, it's fine. But we already saw those primitive types. There are actually many of them that you can reuse. You don't need to create the functional interfaces all the time. You can reuse them if they are compatible with what you want to do. Then the ones that I want us to look at is the binary operator. So let's look at how this binary operator looks like. So we see that the binary operator has a lot of things. Oh, sorry, I'm in the wrong thing here. Binary operator, there you go. So the method we are looking for here is not defined in the binary operator. You see that it inherits from by function, and we saw that by function takes two things as an input, and then in the apply method returns one thing. Takes two things and return one thing. But when you make it binary, it means everything is the same. The two parameters and the input is the same. That is the whole thing about the binary operator. As you can see, it actually inherits from the by function. Then we have the unary operator. So unary operator, let's see it. Unary operator. We see that it extends from function. And we know what function does. Function takes one parameter and returns some other parameter. So if we were to come here, you have a type T as a parameter and a return type. They are different, as you can see. But unary operator, you actually making them to be different, to be the same. So basically, you are saying the input parameter is the same as the return type. That's the purpose of the unary operator. So we see that we also have some specializations of it, or the types of it, as you can see. Int unary operator, let's see how it's defined. So you see that int unary operator, it says it also falls under the primitive. It says represents an operation on a single valued operand that produces an int valued result. This is the primitive type specialization of a unary operator. You see, it takes int, returns an int, as it's mentioned. Let's see double unary operator. Already it's self-explanatory. Let's see. Obviously, it will take a double and return a double on its apply as double method. So if we paste this one here, you see apply as double. So obviously we will have something like long unary operator. You see apply as long. So these are some specializations of the unary operator, but they are still falling under primitive types, specializations of the unary operator. So I'm not sure if we have others, but the list is not exhaustive, as I always say. We have a lot of these things in your code. So I'm just gonna demonstrate to you guys how you can make use of the binary operator, just for as I did with the others. That's the only one I'm gonna work on for now. So we see that binary operator uses by function. We take two stuff that are okay. We can start with binary. Let's start with by function. So we saw that by function, I'm just gonna code it quickly. You have two things, integer, then you want to return whether that is odd. I'm just gonna say boolean here. Then okay, so we can say integer boolean. So what we can do, we can say is multiple. I didn't plan about these things, guys, so sorry, sometime I have to think. So what we are doing here, we want to check if this maybe this number is a multiple of this one. That's the basic thing we want to do. So what we could do, if we want to check if this is a multiple of this, so what we could do, we could say okay, so this is how you will define the method. So its method takes two parameters and it returns a boolean. So if I was to leave this thing like this, this will be true, because this will be valid, sorry, because the method in a functional interface takes two parameters and returns something. And in our own definition, we are taking two integers and we are returning a boolean. So if I put something that is not a boolean here, it's going to be false. Sorry, it's going to be invalid. So this is a perfect a valid definition of this functional interface. When you are creating a lambda, this is a valid lambda for the functional interface. So now, if you were to provide an implementation here, you could perhaps say, although we know that we advise that lambdas should be one clue code, which implies just one line of code, we can do something like x. So we want to check if x is a multiple of y. So we can say y divided by x equals to 0. I'm not sure, guys, if this is how you define the multiple of something. I'm just trying to give a demonstration here. So now if I say out is multiple, so what do I want to check? Is 9 a multiple of 3? So method call expected. So what is it that we expected to do here? Okay, let me say it returns R. Oh my goodness, sorry. I made a mistake. So I have to say apply. My bad. 9 a multiple of 3. Let's run this code. It's true. It's 7 a multiple of 3. It still says true. So I always get this thing wrong. Sorry, guys. I actually have to say modulus operator. If when you divide y by x, the remainder is 0, then it's a multiple. My bad. I'm always confusing these two. So we see that 7 is false. It's not a multiple of 3. Let's see 9. We see that it says 9. It says 9 is not a multiple of 3. So 9 divided by 3 should be... Oh my god, the order is wrong here. I should actually do it like this. I'm wrong. So this should be true. Yes. So if I put 9, 7, sorry, this should be false. Yes. So yeah. Like I said, guys, I didn't plan this, so please excuse my mistake, but that's the way we learn. If you had a perfect code, you were not going to be able to learn like really well. But yeah, this is the definition of it. Or if you want, you can just take this as we mentioned in the previous tutorials, and then you can just put it like this. It's still a correct definition. Or if you don't want to do this, you can make it a method reference and put it somewhere else and do your own things. So normally you would really need to make it a method reference, because you find that the code actually does quite a lot of things for you. So now let's say we are talking about a binary operator now. So we demonstrated a binary function. So what we need to do here is, we know that our function, if it's a binary operator, takes 2 integers, returns an integer. So we can just say sum of 2 integers. That could be an example. So we're going to say x plus y. So this is it. It says can be replaced by a method reference. So I guess that should be maybe, is it math.sum? Okay, let's see that method reference that the compiler is giving us. Yes, integer.sum, my bad. Yeah, I know that sum was involved there. So we see that integer.sum will take and apply that for us. So let's just say sum.apply. So we're going to get 10 there. So this sum, when it's like this, it means it's a static method inside this integer class. So let's review it. As you can see, it's a static method. It takes 2 parameters. It returns an int. So we see that this is actually compatible with our functional interface, because it takes 2 integers and it returns an integer in its definition. So when we have it like this, it works. If we were to put long here, we are in trouble, because now we are relying on something that takes int and returns an int, but our binary wants something that takes a long, 2 parameter longs and returns a long. So we need to do this. for it to work. But now our parameters here are by default integers. So to make it a long, we'll have to tell the compiler that this is a long like this. Then we'll have the same answer. So you can actually play around with these things, guys. So we are not going to do method references. We already touched on our own custom lambdas. So in terms of lambdas, this is the last lecture on lambdas.